The graphics display resolution describes the width and height dimensions of a display, such as a computer monitor, in pixels. Certain combinations of width and height are standardized and typically given a name and an initialism that is descriptive of its dimensions. A higher display resolution in a display of the same size means that displayed content appears sharper. Aspect ratio. The gradual change of the favored aspect ratio of mass-market display industry products, from 4:3, then to 16:10, and then to 16:9, has made many of the display resolutions listed in this article difficult to obtain in mass-market products. The 4:3 aspect ratio generally reflects older products, especially the era of the cathode ray tube. The 16:10 aspect ratio had its largest use in the 1995–2010 period, and the 16:9 aspect ratio tends to reflect the current mass-market computer monitor, laptop, and entertainment products displays. In many cases the resolutions listed in the sections below may have a small market, may only be seen in specialized industrial or computer market products, or may not be available for sale. The 4:3 aspect ratio was common in older television cathode ray tube displays, which were not easily adaptable to a wider aspect ratio. When good quality alternate technologies and plasma displays became more available and less costly, around the year 2000, the common computer displays and entertainment products moved to a wider aspect ratio, first to the 16:10 ratio. The 16:10 ratio allowed some compromise between showing older 4:3 aspect ratio broadcast TV shows, but also allowing better viewing of widescreen movies. However, around the year 2005, entertainment industry displays gradually moved from 16:10 to the 16:9 aspect ratio, for further improvement of viewing widescreen movies. By about 2007, virtually all mass-market entertainment displays were 16:9. In 2011, 1920x1080 was the favored resolution in the most heavily marketed entertainment market displays. The next standard, 3840x2160, emerged in 2013, but movies and TV stations do not support that resolution yet. Also in 2013, displays with 2560x1080 appeared. The computer display industry maintained the 16:10 aspect ratio longer than the entertainment industry, but in the 2005–2010 period, computers were increasingly marketed as dual-use products, with uses in the traditional computer applications, but also as means of viewing entertainment content. In this time frame, with the notable exception of Apple, almost all desktop, laptop, and display manufacturers gradually moved to promoting only 16:9 aspect ratio displays. By 2011, the 16:10 aspect ratio had virtually disappeared from the Windows laptop display market. One artifact is that the highest available resolutions moved downward in this time frame. Video graphics array. QVGA, quarter QVGA denotes a resolution of 160x120 or 120x160 pixels, usually used in displays of handheld devices. The term quarter QVGA signifies a resolution of 1/4 the number of pixels in a QVGA display, which itself is 1/4 the number of pixels in a VGA display. The abbreviation QVGA may be used to distinguish quarter from quad, just like QVGA. HQVGA, half QVGA denotes a display screen resolution of 240x160 or 160x240 pixels, as seen on the Game Boy Advance. This resolution is half of QVGA, which is itself a quarter of VGA, which is 640x480 pixels. QVGA. The quarter video graphics array is a popular term for a computer display with 320x240 display resolution. QVGA displays are most often used in mobile phones, personal digital assistants, and some handheld game consoles. Often the displays are in AA-OE portrait orientation and are referred to as 240x320. The name comes from having a quarter of the 640x480 maximum resolution of the original IBM VGA display technology, which became a de facto industry standard in the late 1980s. QVGA is not a standard mode offered by the VGA BIOS, even though VGA and compatible chipsets support a QVGA-sized Mode X. the term refers only to the display's resolution, and thus the abbreviated term QVGA or quarter VGA is more appropriate to use. QVGA resolution is also used in digital video recording equipment as a low-resolution mode requiring less data storage capacity than higher resolutions, typically in still digital cameras with video recording capability, and some mobile phones. Each frame is an image of 320x240 pixels. QVGA video is typically recorded at 15 or 30 frames per second. QVGA mode describes the size of an image in pixels, commonly called the resolution. Numerous video file formats support this resolution. While QVGA is a lower resolution than VGA, at higher resolutions the Q prefix commonly means quadruple, or 4 times higher display resolution. To distinguish quarter from quad, lowercase q is sometimes used for quarter, and uppercase Q for quad, by analogy with SI prefixes like mm and pp, but this is not a consistent usage. Some examples of devices that use QVGA display resolution include Samsung i5500, LG Optimus L3E400, Galaxy Fit, Lion Pocket, HTC Wildfire, Sony Ericsson XPERI A1010 Mini and Mini Pro, and Nintendo 3DS bottom screen. WQVGA, wide QVGA or WQVGA is any display resolution having the same height in pixels as QVGA, but wider. This definition is consistent with other wide versions of computer displays. Since QVGA is 320 pixels wide and 240 pixels high, the resolution of a WQVGA screen might be 360x240, 384x240, 400x240, 428x240 or 432x240. As with WVGA, exact ratios of n/9 are not practical because of the way VGA controllers internally deal with pixels. For instance, when using graphical combinatorial operations on pixels, VGA controllers will use 1 bit per pixel. Since bits cannot be accessed individually but by chunks of 16 or an even higher power of 2, this limits the horizontal resolution to a 16-pixel granularity, that is, the horizontal resolution must be divisible by 16. In the case of 16:9 ratio, with 240 pixels high, the horizontal resolution should be 240/9 times 16 equals 426.6, the closest multiple of 16 is 432. WQVGA has also been used to describe displays that are not 240 pixels high, for example 16th HD 1080 displays which are 480 pixels wide and 270 or 272 pixels high. This may be due to QVGA having the nearest screen height. WQVGA resolutions are commonly used in touchscreen mobile phones, such as 400x240, 432x240, and 480x240. For example, the Sony Ericsson Uno and the Samsung Instinct both have WQVGA screen resolutions Euro 240x432. Other devices such as the Apple iPod Nano also use a WQVGA screen, 240x376 pixels. HVGA screens have 480x320 pixels, 480x360 pixels, 480x272 or 640x240 pixels. The former is used by a variety of PDA devices, starting with the Sony Clear Permel Pegana 70 in 2002, and standalone PDAs by Palm. The latter was used by a variety of handheld PC devices. VGA resolution is 640x480. Examples of devices that use HVGA include the Apple iPhone 2GA Euro 3GS, BlackBerry Bold 9000, HTC Dream, Hero, Wildfire S, LG GW620 EVE, MyTouch 3G Slide, Nokia 6260 Slide, Palm Pre, Samsung M900 Moment, Sony Ericsson XPERI A108, Mini, Mini Pro, Active and Live. Texas Instruments produces the DLP Pico projector which supports HVGA resolution. HVGA was the only resolution supported in the first versions of Google Android, up to release 1.5. Other higher and lower resolutions are now available starting on release 1.6, like the popular WVGA resolution on the Motorola Droid or the QVGA resolution on the HTC T2. Three-dimensional computer graphics common on television throughout the 1980s were mostly rendered at this resolution, causing objects to have jagged edges on the top and bottom when edges were not anti-aliased. VGA. Video Graphics Array refers specifically to the display hardware first introduced with the IBM PS/2 line of computers in 1987, but through its widespread adoption has also come to mean either an analog computer display standard, a 15-pin D-sub-miniature VGA connector or the 640x480 resolution itself. While this resolution was superseded in the personal computer market in the 1990s, it became a popular resolution on mobile devices in the 2000s. VGA is still the universal fallback troubleshooting mode in the case of trouble with graphic device drivers in operating systems. WVGA, Wide VGA or WVGA, sometimes just WGA, an abbreviation for Wide Video Graphics Array, is any display resolution with the same 480 pixel height as VGA but wider, such as 720x480, 800x480, 848x480, 852x480, 853x480 or 854x480. It is a common resolution among LCD projectors and later portable and handheld Internet-enabled devices as it is capable of rendering websites designed for an 800 wide window in full page width. Examples of handheld Internet devices, without phone capability, with this resolution include SPY Stellar NHANC EMI 435, ASUSEA PC 700 series, Dell 35 East Caribbean dollars, Nokia 770, N800, and N810. Mobile phones with WVGA display resolution are also common. A list of mobile phones with WVGA display is available. FWVGA. FWVGA is an abbreviation for Full Wide Video Graphics Array, which refers to a display resolution of 854x480 pixels. 854x480 is approximately the 16:9 aspect ratio of anamorphically unsqueezed NTSC DVD widescreen video and considered a safe resolution that does not crop any of the image. It is called Full WVGA to distinguish it from other, narrower WVGA resolutions which require cropping 16:9 aspect ratio high-definition video. The 854 pixel width is rounded up from 853.3. 480x16 a 9 equals 7680 a 9 equals 8531 a 3. Since a pixel must be a whole number, rounding up to 854 ensures inclusion of the entire image. Due to physical devices often being manufactured with pixel resolutions that are multiples of 16, the horizontal resolution of 854 may be implemented by the OS simply pretending the 10 edgemost columns, from a full physical width of 864, don't exist. In 2010, mobile phones with FWVGA display resolution started to become more common. A list of mobile phones with FWVGA displays is available. In addition, the Wii U gamepad that comes with the Nintendo Wii U gaming console includes a 6.2-inch FWVGA display. SVGA. Super Video Graphics Array, abbreviated to Super VGA or SVGA, also known as Ultra Video Graphics Array, abbreviated to Ultra VGA or UVGA, is a broad term that covers a wide range of computer display standards. Originally, it was an extension to the VGA standard first released by IBM in 1987. Unlike VGA, a purely IBM-defined standard, Super VGA was defined by the Video Electronics Standards Association, an open consortium set up to promote interoperability and define standards. When used as a resolution specification, in contrast to VGA or XGA for example, the term SVGA normally refers to a resolution of 800x600 pixels. The marginally higher resolution 832x624 is the highest 4:3 resolution not greater than 219 pixels, with its horizontal dimension a multiple of 32 pixels. This enables it to fit within a frame buffer of 512 kilobytes, and the common multiple of 32 pixels constraint is related to alignment. For these reasons this resolution was available on the Macintosh LC3 and other systems. DVGA screens of 960x640 pixels. Both dimensions are double that of HVGA, hence the pixel count is quadrupled. Examples of devices that use DVGA include the Meizu MX mobile phone and the Apple iPhone 4/4S, where the screen is called the Retina display. WSVGA, the wide version of SVGA is known as WSVGA, featured on ultra-mobile PCs, netbooks, and tablet computers. The resolution is either 1024x576 or 1024x600 with screen sizes normally ranging from 7 to 10 inches. Extended Graphics Array. XGA. The Extended Graphics Array is an IBM display standard introduced in 1990. Later it became the most common appellation of the 1024x768 pixels display resolution, but the official definition is broader than that. It was not a new and improved replacement for SuperVGA, but rather became one particular subset of the broad range of capabilities covered under the SuperVGA umbrella. The initial version of XGA expanded upon IBM's older VGA by adding support for 4 new screen modes, including one new resolution, 640x480 pixels in direct 16 bits per pixel RGB high color and 8bpp palette indexed mode. 1024x768 pixels with a 16 or 256 color palette, using a low-frequency interlaced refresh rate. Like the 8514, XGA offered fixed-function hardware acceleration to offload processing of 2D drawing tasks. Both adapters allowed offloading of line draw, bitmap copy, and color fill operations from the host CPU. XGA's acceleration was faster than 8514's, and more comprehensive, supporting more drawing primitives, the VGA Res high color mode, versatile brush, and mask modes, system memory addressing functions, and a single simple hardware sprite typically used to providing a low CPU load mouse pointer. It was also capable of wholly independent function, as it incorporated support for all existing VGA functions and modes. The 8514 itself was a simpler add-on adapter that required a separate VGA to be present. It should be noted that, as they were designed for use with IBM's own range of fixed-frequency monitors, neither adapter offered support for 800x600 SVGA modes. XGA2 added a 24-bit DAC, but this was used only to extend the available master palette in 256 color mode, for example to allow true 256 grayscale outputs instead of the 64 gray levels previously available. There was still no direct true color mode despite the adapter featuring enough default onboard VRAM to support it. Other improvements included provision of the previously missing 800x600 resolution in up to 65,536 colors, faster screen refresh rates in all modes, and improved accelerator performance and versatility. IBM licensed the XGA technology and architecture to certain third-party hardware developers, and its characteristic modes were aped by many others. These accelerators typically did not suffer from the same limitations on available resolutions and refresh rate, and featured other now standard modes like 800x600 at various color depths and interlaced, non-interlaced and flicker-free refresh rates even before the release of the XGA2. All standard XGA modes have a 4:3 aspect ratio with square pixels, although this does not hold for certain standard VGA and third-party extended modes. XGA should not be confused with EVGA, a contemporaneous VESA standard that also has 1024x768 pixels. It should also not be confused with the Expanded Graphics Adapter, a peripheral for the IBM 3270 PC which can also be referred to as XGA. WXGA, Wide Extended Graphics Array is a set of non-standard resolutions derived from the XGA display standard by widening it to a widescreen aspect ratio. WXGA is commonly used for low-end LCD TVs and LCD computer monitors for widescreen presentation. The exact resolution offered by a device described as WXGA can be somewhat variable owing to a proliferation of several closely related standards optimized for different uses and derived from different bases. 1366x768. When referring to televisions and other monitors intended for consumer entertainment use, WXGA is generally understood to refer to a resolution of 1366x768, with an aspect ratio of very nearly 16:9. The basis for this otherwise odd-seeming resolution is similar to that of other wide standards. The line scan rate of the well-established XGA standard extended to give square pixels on the increasingly popular 16:9 widescreen display ratio without having to affect major signaling changes other than a faster pixel clock, or manufacturing changes other than extending panel width by January 3. As 768 does not divide exactly into 9, the aspect ratio is not quite 16:9. This would require a horizontal width of 1365.33 pixels. However, at only 0.05%, the resulting error is insignificant. In 2006, 1366x768 was the most popular resolution for liquid crystal display televisions. By 2013, even this was relegated to only being used in smaller or cheaper displays, cheaper laptop and mobile tablet computers, and mid-range home cinema projectors, having otherwise been overtaken by higher Full HD resolutions such as 1920x1080. 1360x768. A common variant on this resolution is 1360x768, which confers several technical benefits. Most significantly a reduction in memory requirements from just over to just under 1 MB per 8-bit channel, which simplifies architecture and can significantly reduce the amount of and speed of VRAM required with only a very minor change in available resolution, as memory chips are usually only available in fixed megabyte capacities. For example, at 32-bit color, a 1360x768 frame buffer would require only 4 MB, whilst a 1366x768 one may need 5, 6 or even 8 MB depending on the exact display circuitry architecture and available chip capacities. The 6-pixel reduction also means each line's width is divisible by 8 pixels, simplifying numerous routines used in both computer and broadcast theatrical video processing, which operate on 8-pixel blocks. Historically, many video cards also mandated screen widths divisible by 8 for their lower color, planar modes to accelerate memory accesses and simplify pixel position calculations, and this convention still persisted in low-end hardware even into the early days of widescreen, LCD HD TVs. Thus, most 1366-width displays also quietly support display of 1360-width material, with a thin border of unused pixel columns at each side. This narrower mode is of course even further removed from the 16:9 ideal, but the error is still less than 0.5% and should be imperceptible. 1280x800, when referring to laptop displays or independent displays and projectors intended primarily for use with computers, WXGA is also used to describe a resolution of 1280x800 pixels, with an aspect ratio of 16:10. This was once particularly popular for laptop screens, usually with a diagonal screen size of between 12 and 15 inches, as it provided a useful compromise between 43XGA and 16:9 WXGA, with improved resolution in both dimensions versus the old standard, a perceptibly wider appearance and the ability to display 720p HD video native with only very thin letterbox borders and no stretching. Additionally, like 1360x768, it required only 1000 kilobytes of memory per 8-bit channel. Thus, a typical double-buffered 32-bit color screen could fit within 8 megabytes, limiting everyday demands on the complexity of integrated graphics chipsets and their shared use of typically sparse system memory, at least when only the internal display was in use. 16:10 is itself a rather classic computer aspect ratio, harking back all the way to early 320x200 modes as seen in the Commodore 64, IBM SVGA card and others. However, as of mid-2013, this standard is becoming increasingly rare, crowded out by the more standardized and thus more economical to produce 1366x768 panels, as its previously beneficial features become less important with improvements to hardware, gradual loss of general backwards software compatibility, and changes in interface layout. As of August 2013, the market availability of panels with 1280x800 native resolution had been generally relegated to data projectors or niche products such as convertible tablet PCs and LCD-based e-book readers. Additionally, two other resolutions are sometimes labeled as WXGA. First, the HDTV standard 1280x720, which offers an exact 16:9 aspect with square pixels. Naturally, it displays standard 720p HD video material without stretching or letterboxing and 1080i/1080p with a simple 2:3 downscale. This resolution has found some use in tablets and modern, high-pixel density mobile phones, as well as small-format netbook, or ultralight laptop computers. However, its use is uncommon in larger, mainstream devices as it has insufficient vertical resolution for the proper use of modern operating systems such as Windows 7, whose UI design assumes a minimum of 768 lines. For certain users such as word processing, it can even be considered a slight downgrade. The second variant, 1280x768, can be seen as a compromise resolution that addressed this problem, as well as a halfway house between the older 1024x768 and 1280x1024 resolutions, and a stepping stone to 1366x768 and 1280x800, that never quite caught on in the same way as either of its arguably derivative successors. Its square pixel aspect ratio is 15:9, in contrast to HDTV's 16:9 and 1280x800's 16:10. It is also the lowest resolution that might be found in an Ultrabook standard laptop, as it satisfies the minimum horizontal and vertical pixel resolutions required to officially qualify for the designation. Recent widespread availability of 1280x800 and 1366x768 pixel resolution LCDs for laptop monitors can be considered an OS-driven evolution from the formerly popular 1024x768 screen size, which has itself since seen UI design feedback in response to what could be considered disadvantages of the widescreen format when used with programs designed for traditional screens. In Microsoft Windows operating system specifically, the larger taskbar of Windows Vista and 7 occupies an additional 16 pixel lines by default, which may compromise the usability of programs that already demanded a full 1024x768 unless it is specifically set to use small icons. An audible 784-line resolution would compensate for this, but 1280x800 has a simpler aspect and also gives the slight bonus of 16 more usable lines. Also, the Windows sidebar in Windows Vista and 7 can use the additional 256 or 336 horizontal pixels to display informational widgets without compromising the display width of other programs, and Windows 8 is specifically designed around a two-pane concept where the full 16:9 or 16:10 screen is not required. Typically, this consists of a 4:3 main program area plus a narrow sidebar running a second program, showing a toolbox for the main program or a pop-out OS shortcut panel taking up the remainder. Some 1440x900 resolution displays have also been found labeled as WXGA. However, the correct label is actually WSXGA or WXGA+. XGA+ stands for Extended Graphics Array Plus and is a computer display standard, usually understood to refer to the 1152x864 resolution with an aspect ratio of 4:3. Until the advent of widescreen LCDs, XGA+ was often used on 17-inch desktop CRT monitors. It is the highest 4:3 resolution not greater than 220 pixels, with its horizontal dimension a multiple of 32 pixels. This enables it to fit closely into a video memory or frame buffer of 1 MB, assuming the use of 1 byte per pixel. The common multiple of 32 pixels constraint is related to alignment. Historically, the resolution also relates to the earlier standard of 1152x900 pixels, which was adopted by Sun Microsystems for the Sun II workstation in the early 1980s. A decade later, Apple Computers selected the resolution of 1152 x 870 for their 21-inch CRT monitors, intended for use as two-page displays on the Macintosh II computer. These resolutions are even closer to the limit of a 1 MB frame buffer, but their aspect ratios differ slightly from the common 4:3. XGA Plus is the next step after XGA, although it's not approved by any standard organizations. The next step with an aspect ratio of 4:3 is 1280 x 960 or SXGA Plus. WXGA Plus, WXGA Plus and WSXGA are non-standard terms referring to computer display resolutions. Usually they refer to a resolution of 1440 x 900, but occasionally manufacturers use other terms to refer to this resolution. The Standard Panels Working Group refers to the 1440 x 900 resolution as WXGA, 2. WSXGA and WXGA Plus can be considered enhanced versions of WXGA with more pixels, or as widescreen variants of SXGA. The aspect ratios of each are 16:10. WXGA Plus resolution is common in 19 inches widescreen desktop monitors, and is also optional, although less common, in laptop LCDs, in sizes ranging from 12.1 to 17. It is also used in the 13-inch MacBook Air. With a 13.3-inch screen this is 128 ppi. The other one is 1440 x 960, which is 1510. SXGA. SXGA is an abbreviation for Super Extended Graphics Array referring to a standard monitor resolution of 1280 x 1024 pixels. This display resolution is the next step above the XGA resolution that IBM developed in 1990. The 1280 x 1024 resolution is not the standard 4:3 aspect ratio, but 5:4. A standard 4:3 monitor using this resolution will have rectangular rather than square pixels, meaning that unless the software compensates for this the picture will be distorted, causing circles to appear elliptical. There is a less common 1280 x 960 resolution that preserves the common 4:3 aspect ratio. It is sometimes unofficially called SXGA to avoid confusion with the standard SXGA. Elsewhere this 4:3 resolution was also called QVGA, since both sides are doubled from VGA. The term QVGA would be a systematic one, but it is hardly ever used, because its initialism QVGA is strongly associated with the alternate meaning quarter VGA. SXGA is the most common native resolution of 17 inches and 19 LCD monitors. An LCD monitor with SXGA native resolution will typically have a physical 5:4 aspect ratio, preserving a 1:1 pixel aspect ratio. Sony manufactured a 17 inches CRT monitor with a 5:4 aspect ratio designed for this resolution. It was sold under the Apple brand name. SXGA is also a popular resolution for cell phone cameras, such as the Motorola Razr ZR and most Samsung and LG phones. Although being taken over by newer WXGA cameras, the 1.3 megapixel was the most common around 2007. Any port that can run 1280 x 1024 can also run 1280 x 960, which has the standard 4:3 ratio. Displaying any 4:3 resolution on a 5:4 monitor, like a TFT with a native resolution of 1280 x 1024, will look stretched. But on a TFT, displaying any other resolution than the native one is not a good idea anyway, as the image needs to be interpolated to fit in the fixed grid display. The 1280 x 1024 resolution became popular because at 24-bit color it fit well into 4 MB of video RAM. At the time, memory was extremely expensive. Using 1280 x 1024 at 24-bit color depth allowed using 3.75 MB of video RAM, fitting nicely with VRAM chip sizes which were available at the time. 1280 x 1024, PXX 8-bit PXO 8-bit byte at 220 byte MB equals 1.25 MB, 1280 x 1024, PXX 24-bit PXO 8-bit byte at 220 byte MB equals 3.75 MB. SXGA+. SXGA+ stands for Super Extended Graphics Array Plus and is a computer display standard. An SXGA+ display is commonly used on 14-inch or 15-inch laptop LCD screens with a resolution of 1400 x 1050 pixels. An SXGA+ display is used on a few 12-inch laptop screens such as the ThinkPad X60 and X61 as well as the Toshiba Porter Copyright GA Copyright M200 and M400, but those are far less common. At 14.1 inches, Dell offered SXGA+ on many of the Dell Latitude C-series laptops, such as the C640 and the C810, and Lenovo on the ThinkPad T61 and T61P. Sony also used SXGA+ in their Z1 series, but no longer produce them as widescreen has become more predominant. There is a widescreen version of SXGA+ called WSXGA+ with a resolution of 1680 x 1050. This is a common native resolution of 19/22-inch wide aspect LCD monitors, and is also available on many laptops. It is the next common step in resolution after SXGA, although it is not approved by any organization. The most common resolution immediately above is called QXGA, which has 1600 x 1200 pixels. In desktop LCDs, SXGA+ is used on some low-end 20-inch monitors, whereas most of the 20-inch LCDs use QXGA, or WSXGA+. WSXGA+ stands for Widescreen Super Extended Graphics Array Plus and is a computer display standard. A WSXGA+ display is commonly used on widescreen 20 inches, 21, and popular 22 LCD monitors from numerous manufacturers, as well as widescreen 15.4 and 17 laptop LCD screens like the ThinkPad T61 and the Apple 15 MacBook Pro. The resolution is 1680 x 1050 pixels and has a 16:10 aspect ratio. WSXGA+ is the widescreen version of SXGA+, but it is not approved by any organization. The next highest resolution after it is WXGA, which is 1920 x 1200 pixels. UXGA, UXGA or UGA is an abbreviation for Ultra Extended Graphics Array referring to a standard monitor resolution of 1600 x 1200 pixels, which is exactly 4 times the default resolution of SVGA. Dell Incorporated refers to the same resolution of 1,920,000 pixels as UGA. It is generally considered to be the next step above SXGA, but some resolutions fit between the two. UXGA has been the native resolution of many full-screen monitors of 15 inches or more, including laptop LCDs such as the ones in ThinkPad A21p, A30p, A31p, T42p, T43p and T60p. Dell Inspiron 80,008,200. Panasonic Toolbook CF51. And the original Alienware Area 51M. However, in more recent times, UXGA is not used in laptops at all but rather in desktop UXGA monitors that have been made in sizes of 20 inches and 21.3. Some 14 inches laptop LCDs with UXGA have also existed, but these were very rare. There are 2 different widescreen cousins of UXGA, one called WXGA with 1600 x 768 and one called WXGA with 1920 x 1200 resolution. WXGA, WXGA stands for Widescreen Ultra Extended Graphics Array and is a display resolution of 1920 x 1200 pixels with a 16:10 screen aspect ratio. It is a wide version of UXGA, and can be used for viewing high-definition television content, which uses a 16:9 aspect ratio and a 1920 x 1080 resolution. The 16:10 aspect ratio was chosen because this aspect ratio is appropriate for displaying 2 full pages of text side by side. WXGA resolution is 2.304 megapixels. An uncompressed 8-bit RGB WXGA image has a size of 6.6 megabytes. As of 2014, this resolution is available in a few high-end LCD televisions and computer monitors, although in the past it was used in a wider variety of displays, including 17 inches laptops. WXGA use predates the introduction of LCDs of that resolution. Most QXGA displays support 1920x1200 and widescreen CRTs such as the Sony GDM-FW900 and Hewlett-Packard A7217A do as well. The next lower resolution before it is WSXGA+, which is 1680x1050 pixels. The next higher resolution widescreen is an unnamed 2304x1440 resolution, and then the more common WQXGA, which has 2560x1600 pixels. There are two wider formats called UWXGA 1600x768 and UWXGA that has 2560x1080 pixels, a 2.371 or 21:9 or 64:27 aspect ratio, sometimes erroneously labeled 21:9. Quad Extended Graphics Array, the QXGA, or Quad Extended Graphics Array, display standard is a resolution standard in display technology. Some examples of LCD monitors that have pixel counts at these levels are the Dell 3008 WFP, the Apple Cinema display, the Apple iMac, the iPad, and the MacBook Pro. Many standard 21 inches/22 CRT monitors and some of the highest-end 19 CRTs also support this resolution. QWXGA QWXGA is a display resolution of 2048x1152 pixels with a 16:9 aspect ratio. A few LCD QWXGA monitors were available in 2009 with 23 and 27-inch displays, such as the Acer B233HU and B273HU, the Dell SP2309W, and the Samsung 2343BWX. As of 2011, most 2048x1152 monitors have been discontinued, and as of 2013 no major manufacturer produces monitors with this resolution. QXGA QXGA is a display resolution of 2048x1536 pixels with a 4:3 aspect ratio. The name comes from it having 4 times as many pixels as an XGA display. Examples of LCDs with this resolution are the IBM T210 and the ASO G33 and A31 screens, but in CRT monitors this resolution is much more common. Some examples include the Sony F520, ViewSonic G225FB, NEC FP2141SB or Mitsubishi DP2070SB, Yamaha Vision Master Pro 514, and Dell and HP P1230. Of these monitors, none are still in production. A related display size is WQXGA, which is a widescreen version. CRTs offer a way to achieve QXGA cheaply. Models like the Mitsubishi Diamond Pro 2045U and IBM ThinkVision C220P retailed for around $200, and even higher performance ones like the ViewSonic Perfect Flat P220FB remained under $500. At one time, many off-lease P1230s could be found on eBay for under $150. The LCDs with WQXGA or QXGA resolution typically cost 4 to 5 times more for the same resolution. ITech manufactured a 15 inches QXGA IPS panel. NEC sold laptops with QXGA screens in 2002 €5 for the Japanese market. The iPad also has a QXGA display. WQXGA WQXGA is a display resolution of 2560x1600 pixels with a 16:10 aspect ratio. The name comes from it being a wide version of QXGA and having 4 times as many pixels as an WXGA display. To obtain a vertical refresh rate higher than 40 Hz, this resolution requires more bandwidth than a single-link DVI supports and requires dual-link capable cables and devices. To avoid cable problems, monitors are sometimes shipped with an appropriate dual-link cable already plugged in. Many video cards support this resolution. One feature that is currently unique to the 30 inches WQXGA monitors is the ability to function as the centerpiece and main display of a 3-monitor array of complementary aspect ratios, with 2 UXGA 20 monitors turned vertically on either side. The resolutions are equal, and the size of the 1600 resolution edges is within 1/10 of an inch, presenting a picture window view without the extreme lateral dimensions, small central panel, asymmetry, resolution differences, or dimensional difference of other three monitor combinations. The resulting 4960x1600 composite image has a 3.1:1 aspect ratio. This also means one WXGA 20 inches monitor and portrait orientation can also be flanked by two 30 WQXGA monitors for a 6320x1600 composite image with an 11.85:3 aspect ratio. Some WQXGA medical displays can also be configured as two virtual 1200x1600 or 1280x1600 seamless displays by using both DVI ports at the same time. In 2010, WQXGA made its debut in a handful of home theater projectors targeted at the constant heights screen application market. Both Digital Projection Incorporated and Projection Design released models based on a Texas Instrument DLP chip with a native WQXGA resolution, alleviating the need for an anamorphic lens to achieve 1.2.35 image projection. Many manufacturers have 27 inches a €30 models that are capable of WQXGA, albeit at a much higher price than lower resolution monitors of the same size. Several mainstream WQXGA monitors are available with 30-inch displays, such as the Dell Ultra-Sharp 3007 WFPHC, Dell Ultra-Sharp 3008 WFP, U3011 and 3014, the Hewlett-Packard LP3065, the Gateway XHD 3000, LG W3000H, and the Samsung 305T specialist manufacturers like ASO, Planar Systems, Barco, and possibly others offer similar models. Released in November 2012, Google's Nexus 10 is the first consumer tablet to feature WQXGA resolution. Before its release, the highest resolution available on a tablet was QXGA, available on the Apple iPad 3rd and 4th generations devices. The Samsung Galaxy Note 10.1 and Note Pro 8.4, 10.1 and 12.2 tablets also feature a WQXGA resolution display. Qsxga. Qsxga is a display resolution of 2560x2048 pixels with a 5:4 aspect ratio. Gradscale monitors with a 2560x2048 resolution, primarily for medical use, are available from Planar Systems, ASO, Barco, Wide, Itech, and possibly others. Recent medical displays such as Barco Coronis Fusion 10 OMP or NDS Dome S10 have native panel resolution of 4096x2560. These are driven by two dual-link DVI or DisplayPort outputs. They can be considered to be two seamless virtual Qsxga displays as they have to be driven simultaneously by both dual-link DVI or DisplayPort since one dual-link DVI or DisplayPort cannot single-handedly display 10 megapixels. A similar resolution of 2560x1920 was supported by a small number of CRT displays via VGA such as the ViewSonic P225F when paired with the right graphics card. WQXGA. WQXGA describes a display standard that can support a resolution up to 3200x2048 pixels, assuming a 1.56:1 aspect ratio. The Coronis Fusion 6 OMP Dale by Barco supports 3280x2048. QXGA describes a display standard that can support a resolution up to 3200x2400 pixels, assuming a 4:3 aspect ratio. WQXGA. WQXGA describes a display standard that supports a resolution of 3840x2400 pixels, which provides a 16:10 aspect ratio. This resolution is exactly 4 times 1920x1200. WQXGA is the maximum resolution supported by DisplayPort 1.2, though actually displaying such a resolution on a device with DisplayPort 1.2 is dependent on the graphics system in much the same way devices with VGA connectors do not necessarily maximize that standard's highest possible resolution. Most display cards with a DVI connector are capable of supporting the 3840x2400 resolution. However, the maximum refresh rate will be limited by the number of DVI links which are connected to the monitor. 1, 2, or 4 DVI connectors are used to drive the monitor using various tile configurations. Only the IBM T221DG5 and EdTech Maryland 22292B5 support the use of dual-link DVI ports through an external converter box. Many systems using these monitors use at least 2 DVI connectors to send video to the monitor. These DVI connectors can be from the same graphics card, different graphics cards, or even different computers. Motion across the tile boundary, ES, can show tearing if the DVI links are not synchronized. The display panel can be updated at a speed between 0 Hz and 41 Hz. The refresh rate of the video signal can be higher than 41 Hz, but the monitor will not update the display any faster even if graphics card, S, do so. In June 2001, WQXGA was introduced in the IBM T220 LCD monitor using a LCD panel built by EdTech. LCD displays that support WQXGA resolution include IBM T220, IBM T221, Yamaha AQU5611DTBK, ViewSonic VP2290, ADTX Maryland 22292B, and EdTech Maryland 22292. EdTech was the original equipment manufacturer which sold these monitors to ADTX, IBM, Yamaha, and ViewSonic. However, none of the WQXGA monitors are in production anymore. They had prices that were well above even the higher-end displays used by graphic professionals, and the lower refresh rates, 41 Hz and 48 Hz, made them less attractive for many applications. Hyperextended graphics array, the HXGA display standard and its derivatives are a standard in display technology. As of 2012, there is no monitor that displays at these levels, but several digital cameras can record such images. HXGA, an abbreviation for hex, 8-quadruple extended graphics array is a display standard that can support a resolution of 4096 x 3072 pixels with a 4:3 aspect ratio. The name comes from it having 16 times as many pixels as an XGA display. WXGA, an abbreviation for wide hex, 8-quadruple extended graphics array is a display standard that can support a resolution of roughly 5120 x 3200 pixels with a 16:10 aspect ratio. The name comes from it being a wide version of HXGA, which has 16 times as many pixels as an XGA display. HSXGA, an abbreviation for hex, 8-quadruple super extended graphics array, is a display standard that can support a resolution of roughly 5120 x 4096 pixels with a 5:4 aspect ratio. The name comes from it having 16 times as many pixels as an SXGA display. WHSXGA, an abbreviation for wide hex, 8-quadruple super extended graphics array, is a display standard that can support a resolution up to 6400 x 4096 pixels, assuming a 1.56:1 aspect ratio. The name comes from it having 16 times as many pixels as an WSXGA display. Qsxga, an abbreviation for hex, 8-quadruple ultra-extended graphics array, is a display standard that can support a resolution of roughly 6400 x 4800 pixels with a 4:3 aspect ratio. The name comes from it having 16 times as many pixels as an UXGA display. Qsxga, an abbreviation for wide hex, 8-quadruple ultra-extended graphics array, is a display standard that can support a resolution up to 7680 x 4800 pixels, assuming a 16:10 aspect ratio. The name comes from it having 16 times as many pixels as a WXGA display. High definition. NHD is a display resolution of 640 x 360 pixels, which is exactly 1/9 of a full HD frame and 1/4 of a HD frame. Pixel doubling NHD frames will form one 720p frame and pixel tripling NHD frames will form one 1080p frame. One drawback of this resolution is that the vertical resolution is not an even multiple of 16, which is a common macro block size for video codecs. Video frames encoded with 16x16 pixel macro blocks would be padded to 640x368 and the added pixels would be cropped away at playback. H264 codecs have this padding and cropping ability built in as standard. The same is true for QHD and 1080p, but the relative amount of padding is more for lower resolutions such as NHD. To avoid storing the 8 lines of padded pixels, some people prefer to encode video at 624x352, which only has one stored padded line. When such video streams are either encoded from HD frames or played back on HD displays in full screen mode, they are scaled by non-integer scale factors. True NHD frames on the other hand has integer scale factors, for example Nokia 808 PureView with NHD display. QHD QHD is a display resolution of 960x540 pixels, which is exactly 1/4 of a full HD frame, in a 16:9 aspect ratio. Similar to DVGA, this resolution became popular for high-end smartphone displays in early 2011. Mobile phones including the Sony Xperiac, Sony Xperiap, HTC Amaze 4G, HTC Sensation, HTC Evo 3D, HTC Desire 600, Motorola Droid RAZR, Motorola Droid Bionic 4G LTE, Q-Mobile Noir A9, Motorola Atrix 4G, Moto E, LG Optimus L9, LG Optimus F5, Fly F53s and Samsung Galaxy S4 Mini have displays with the QHD resolution, as does the PlayStation Vita portable game system. HD. The HD resolution of 1280x720 pixels stems from high-definition television, where it originally used 60 frames per second. With its 16:9 aspect ratio, it is exactly 2 times the width and 1A1 or 2 times the height of 43VGA, which shares its aspect ratio and 480 line count with NTSC HD, therefore has exactly 3 times as many pixels as VGA. This resolution is sometimes referred to as 720p, although the p is irrelevant for labeling digital display resolutions. Few screens have been built that actually use this resolution natively. Most employ 16:9 panels with 768 lines instead, which resulted in odd numbers of pixels per line, that is 1365A1 or 3 are rounded to 1360, 1364, 1366 or even 1376, the next multiple of 16. All of these resolutions are in scope of the HD Ready label. FHD. The FHD or Full HD resolution of 1920x1080 pixels in a 16:9 aspect ratio was developed as an HD TV transmission and storage format. Using interlacing, the bandwidth requirements are very similar to those of 720p. Their pixel counts are roughly in a 2:1 ratio, 9:4 exactly. FHD is 3 times the width and 2A1 or 4 times the height of 43VGA. Due to its origins, this resolution is sometimes referred to as 1080i, wherein the I stands for interlaced. Since there are also progressive signals with the same frame rate, those signals are more commonly called 1080p. Since most video codecs use 16x16 pixel macro blocks, there is often an excess 8 lines encoded, for 16 × 68 equals 1088. QHD, also sometimes advertised as WQHD due to its widescreen shape, or 1440p, is a display resolution of 2560x1440 pixels in a 16:9 aspect ratio. It has 4 times as many pixels as the 720p HD TV video standard, hence the name. This resolution was under consideration by the ATSC in the late 1980s to become the standard HD TV format, because it is exactly 4 times the width and 3 times the height of VGA, which has the same number of lines as NTSC signals at the SD-TV 4:3 aspect ratio. Pragmatic technical constraints made them choose the now well-known 16:9 formats with twice and thrice the VGA width instead. In autumn 2006, Chimay Optoelectronics announced a 47 inches 1440 LCD panel to be released in Q2 2007. The panel was planned to finally debut at FPD International 2008 in a form of autostereoscopic 3D display. As of the end of 2013, monitors that have a QHD display are becoming more common. A list of monitors with QHD display is available. In autumn 2012, Samsung announced the Series 9 WQHD laptop with a 13 inches 2560x1440 display. In August 2013, LG announced a 5.5 inches QHD smartphone display. In October 2013, Vivo announced a smartphone with a 2560x1440 display. WQXGA+, WQXGA+, also referred to as QHD and QHD+, is a resolution of 3200x1800 in a 16:9 aspect ratio. It has 4 times as many pixels as the 1600x900 HD+ resolution. The first products announced to use this resolution are the 2013 horsepower NV14 Touch Smart Ultrabook and the 13.3 inches Samsung Ativ Q. UHD. UHD is a display resolution of 3840x2160 pixels in the same 16:9 aspect ratio. This resolution is part of the UHD TV standard and is advocated by NHK Science and Technology Research Laboratories. In early 2008, Samsung revealed a proof-of-concept 82-inch LCD TV set capable of this resolution, and LG has demonstrated an 84-inch display. In November 2010, CMI launched a 27.84 inches 158 ppi 4K IPS panel for medical purposes. OpticView has 2 versions of 56 inches 4K monitors. DC801 has 2 dual-link DVI inputs. DC802 has 4 different versions, 4 single-link DVI, 4 HDMI, 4 DisplayPort and or 4 3G SDI inputs. All versions can deliver a resolution of 3840x2160. iEVICE produces a 56 inches LCD named DYE-LCD56 QHD while Toshiba makes the P56 QHD, and in October 2011 released the REG-ZA55X3, which is claimed to be the first 4K glasses-free 3D TV. Mitsubishi Electric the 56P Qf60 LCU, and Sony the SRM-L560, all which can deliver a resolution of 3840x2160. Landmark has also produced a 56 inches 4K monitor, the M5600. Both HDMI 1.4 and DisplayPort 1.2 support 4K, at up to 30 Hz using a single cable. DisplayPort 1.2 can also achieve 60 Hz at this resolution but requires using 2 cables and 2 DisplayPort connectors, per device, linked by multi-stream transport. HDMI 1.4 has no such option, but HDMI 2.0 can achieve 60 Hz. Digital Cinema Initiatives 4K, standard established by the Digital Cinema Initiatives Consortium consisting of 4096 pixels a 2160 lines for 4K film projection. This is the native resolution for DCI-compliant 4K digital projectors and monitors. FUHD. FUHD is a display resolution of 7680x4320 pixels in the same 16:9 aspect ratio. This resolution is part of the UHD TV standard and is advocated by NHK Science and Technology Research Laboratories and the BBC. See also, display resolution, list of mobile phones with HD display, mode 13 hours and mode X, video modes in VGA hardware with a resolution profile similar to QVGA, megapixel, references.